Hi, my name is Deepak Kumar Tyagi and my student ID is 231780119, and the topic of my assignment is a hybrid approach for crop production classification using the environmental indicators. So now let me give you an overview of my work. So this project focuses on, just a moment please. So this project focuses on developing a hybrid machine learning and the deep learning approach for classifying the crop production level using the environmental indicators. Basically, our project combined the three data sets, which are CO2 emissions, crop production, climate change, and the measurement. So the aim of our study is to see how the climate change affects crop and also to build a strong model for the accurate classification. So here we have implemented and combined three different algorithms, which are KNN, CNN, and SVM. So we have implemented these three different algorithms just to predict whether the crop yield will be low, medium, or the high, based on the various environmental and the temporal factors. So now, basically what our project does is it combines all the three data sets and give us whether the uh, predicts whether the crop yield will be low, medium, or high. So now coming to the uh, project now. So we started the data with the data pipeline and cleaning the data. So here we can see we have imported some necessary libraries here, and then we started with uploading the data set first. So here we uploaded the first data set in which we have different columns like the location, indicator, subject, measure frequency, time, flag value, etc. So while uploading the first data set, like we had some unwanted data sets, so we have removed unwanted columns. So here we have removed all those unwanted columns like flag codes, frequency indicators, etc. After that, then we have pre-processed the data set 1. So here we have converted all the values column into the numeric values, calculated the yield production, initialized the yield column to the original crop data frame. And after the pre-processing of the dataset 1, then we uploaded the dataset 2. So here we can see the different rows for our dataset 2. Like we have here the different data rows. Then we process this dataset 2. We pass the mixed data formats, and also we calculated the yearly average temperature per country. So here it came the data set 2. Then coming to the data set 3, we have uploaded here the data set 3. Here are different rows for the data set 3. As we can see, here is the first row for the data set. Row for the data set. It is showing the different countries, and it is showing the temperature of the different countries in the different years. Then we have pre-processed the dataset 3 as well, and we have taken out the country year CO2 emissions. After that, we have merged all the three data sets into one, and then we pre-process that merged data and clean that data. So after that, these are the some graphical representations of our data. Like we can see here, this is the data we have got after the final merging of the data. So like we can see, it is the average temperature trend over the year for our final merged data. And it is the yield versus the average temperature. And we can see the graphical representation for the yield distribution by country. Here is the graphical representation for the total crop production yield by the country. We can see here are the different countries, and it is the crop production per year. And likewise, it is the yearly crop production yield by the country. It is the average temperature of each country, average global CO2 emission over the years, average global temperature versus the CO2 emission. Here we have basically compared the CO2 emissions over the year to the average global temperature. Then after we have the count of classes before sampling, like we basically we can see here whether the yield will be low, medium or the high. So after that, coming to the encoding, we use the label encoder to convert the text data like country, crop, the yield class into the numbers, and min and max scalar to adjust the numerical data like temperature and CO2 emissions. And here we can see the heat map of the countries like for the CO2 emissions and the average temperature per year. Here we have used the decision tree. The decision tree is used to find the important features like identifying the CO2 emissions, subject, country, average temperature over the years. Then we have trained our different models using the different algorithms. So basically, basically, we have tested all three algorithms and checked the performance using accuracy, confusion matrix, and classification of the reports. As there are three algorithms, so each group member worked on one. So I worked on the SVM, which is super vector machine. So coming to the SVM directly. So SVM is basically a strong machine learning algorithm that separates the data into classes like low, medium, and high yields by finding the best dividing line called the hyperlane. So here we can see the confusion matrix for the SVM. It predict the it predicted the values like 732, 658, 812. These are the predictions. And also we have also predicted the latency per prediction, throughput, and all those things. So beyond accuracy, we have also analyzed how fast the SVM model makes predictions. So I measured the latency by running the predictions on many samples and calculating the average time per prediction. We have also measured here the throughput, which is the number of prediction that model can make per second when processing the entire test set at once. So then this is the CNN algo. Now coming to the testing part. Here we have analyzed the impact of climate on the crop yield using the machine learning and deep learning. So basically we have given some inputs, like we have given subject rice year 2009, country Australia, average temperature. So then we encoded all these data to make it a value between 0 to 1. Here it came like value. After that we have got the result as high, so which is basically the best result. So yeah, that's it. And in conclusion, the KNN got the highest accuracy, which is at 99%, and the CNN got the 96%, following the SVM got the 92%. So KNN can be said as the most accurate, but SVM is also the solid option for handling the complex data and relationships. So that's it from my side. Thank you.